You're watching live coverage of NASA's Phoenix mission to Mars from the Jet Propulsion Laboratory in Pasadena, California. After a tense few hours and a harrowing final 7 minutes to the surface, NASA has successfully landed a new spacecraft on Mars. The Mars Phoenix touched down about an hour and a half ago at 4:53 Pacific time. Hello, I'm Gay Hill here at JPL Mission Control. Welcome back. The Phoenix team is now finishing a playback of pre-recorded data from entry, descent, and landing. The team is also looking forward to the first downlink of post-landing information that will be relayed by the Mars Odyssey orbiter. Let's go back into Mission Control right now with Robert Shotwell to get an update on the poll that took place at about 5:30, and we'll know a health and safety poll or status on the spacecraft right now. Let's go to Robert.
Just to recap what we saw here tonight, the EDL event looks like it couldn't have happened better than we planned it. The touchdown velocity, based on the information that we have at the time of touchdown, was less than 0.1 meters per second horizontal velocity, exactly 2.4 meters per second vertical velocity. That was the design value. The lander appears to have a tilt of about 0.3 degrees and is about 0.68 degrees rotation in azimuth about the nominal point. So almost exactly perfectly flat and aligned where we want it to. Initial estimates put the landing latitude at 68.22 degrees and 234.3 degrees longitude. The maximum rate seen on the chute was 34 degrees per second, which is about a third of what the worst case predicts were. At the time of touchdown, our batteries were still at 90% state of charge. We used 37.56 kilograms of propellant during the event, which leaves 16.9 kilos in the tank, which will freeze overnight tonight. The helium pressure was vented as expected, starting at about 4 seconds after touchdown. The parachute deployment occurred about 7 seconds long, or 7 seconds later than initial predicts, which led a little bit to the touchdown location being slightly off axis where we expected it to land, although all these informations are still basically temporary at this point until we get some more data after the next pass, which is due in about 12 minutes. We'll be able to update all of these values and get the precise ones for the record. Other than that, it was a nominal EDL event. Everything looked as good as we could possibly have expected. It almost looked dry labbed. And the EDL team has been thrilled with the results. We've now handed over to the surface mission, and the ops team is taking over from there in Tucson, and now hopefully they're going to make the best of what we just gave them.
And I'd like to remind everyone you're watching live coverage of NASA's Phoenix mission to Mars from the Jet Propulsion Laboratory in Pasadena, California. The Phoenix mission is led by the University of Arizona on behalf of NASA. Project management is by JPL, a division of the California Institute of Technology. The spacecraft development is by Lockheed Martin Space Systems in Denver, Colorado. Well, back here at the interview desk as we await the downlink and possible images from the Phoenix lander, I'm joined by Dan McLeese, JPL's chief scientist. Mars is Dan's specialty, and there's no one better to describe what we'll be seeing later this evening. So, Dan, thanks for joining us.
It's my pleasure.
The information may be coming down any time now, but primarily the stuff that we'll be seeing is mostly engineering.
Yeah, the very first thing we need to do is to determine the health of the spacecraft on the surface. We need to make sure from the images and from just the downlink what it is that we've got. We've got a healthy spacecraft. We've got a spacecraft with the solar cells deployed. Do we have nice firm foot pad positions? What are we going to see? And that, I think, in the next couple of minutes is what we're going to start looking at.
What's actually scheduled? Are we going to get a shot of the foot pad? Are we?
Yes, I think what's planned is we're going to see the solar panels, whether or not they're fully deployed. We are going to be looking at the foot pad. We're going to be looking at the instrument deck in order to see whether the biobarrier, which has up to this point since launch covered the arm and the scoop, to keep them protected from contamination by earth, debris, microbes. We ought to be able to see whether or not the meteorological mast has been deployed. With all of that information, we really will gather quite a lot about the health of the spacecraft.
And we should be getting that anytime now, or there's no way to determine that?
Well, I think within the next few minutes we should, actually. We'll know if we've got some images.
Now, I understand that you have a personal interest on some of the weather images that we'll be seeing, and we have some pictures just from the last few days that we can roll.
Yes, that's right. I do Mars atmospheric science. In fact, the meteorology boom that is on the spacecraft will be making measurements on the surface. Yeah, these are some pictures taken by the orbiters. These are images that show clouds in the Martian atmosphere over the North Polar Cap.
Now, we are learning an awful lot about the weather and about the ice in this region, and we have a lot to kind of compare and correlate with our own poles.
Well, that's right. The comparison between Mars climate and weather and Earth climate and weather have been a subject of discussion for well over 100 years. And we, in fact, have an instrument on board, one of the orbiters that does meteorology, and we have instruments on board the lander that do meteorology, and those will be talking to one another. We're going to be really able to do everything from the surface to about 60 miles above the surface.
All right. Well, we are standing by, and I see some reaction in the University of Arizona, so let's go to the room and see what's happening.
Initial data assessments look positive for Phoenix. We've got looks like a positive state of charge, meaning that the solar rays appear to be out. Looks like images are hitting the ground. They haven't come through on our side yet here in JPL, but it looks like they have seen a few images show up there in the Science Operations Center in Tucson, which is a very good sign. This pass that we're doing right now will last for another 5 or 6 minutes, and we'll continue to get additional data down. But right now, everything is looking very good on the lander.